Hi, in this lecture we'll discuss Verilog HDL. HDL stands for Hardware Descriptive Language. Verilog is one of the most used HDL in the industry. Now, Verilog is, as we already discussed, Verilog is most popular among the hardware engineers or designers, unlike VHDL, which is used in research and academic use. So here we discuss what is Verilog, how to design circuits using Verilog. So why should we learn? First of all, it is fun, it is enjoyable for a person who are non-digital electronics. It is very interesting to apply his knowledge, and you can make a living using Verilog, because your hardware industry or electronic hardware industry relies on HDL in around 70% of this industry requirement, from testing to design and R&D. And another point is VHDL is another contender of Verilog in HDL industry. It is better than writing it, because Verilog or VHDL is much lengthier and much complicated or much than Verilog. And it's up to one's choice and taste, which one likes it. So let's go ahead with Verilog. Now, I have taken this slide because beating a super grandmaster is, so we are thinking of see of the robot. The robot is playing the chess with 3 opponents at the same time, and they are super grandmasters. They may be super grandmasters, and he can easily beat those super grandmasters, because right now in AI field, using the deep learning or even using the conventional algorithms like min-max and alpha beta pruning, we don't have any human grandmaster, even super grandmasters, even world champion who can beat a computer or software in chess. This is true. We have Stockfish was one of the world's best software who can beat any world champion with ease. And now we have another AI deep learning based AlphaZero, which can beat even Stockfish in no time. So the main point of this slide is, when you're going for hardware or a product or embedded system of any purposes, we need application specific integrated circuits or FPGA or any chip which can customize for our particular applications. How to do this? We'll go ahead. Now there's some other applications like drones. These days we have drones is used in security, entertainment, and even multimedia applications, as well as for all those many applications, research purposes, etc. So how can design a custom drone? What are the requirements? Yeah, when we compare to one application, for example, image processing, we have a drone, have a camera, and it can be used for research, it can be surveillance, security, even border, etc. So when the camera inbuilt within or embedded within the drone is capturing something, it has to be processed. And when it has to be processed, means the information within the image, that means it can be detecting an intruder, it can be detecting a infrared. Here we have shown infrared camera giving a thermal image to the drone, and then drone process it. So how it is possible? The drone is just a small thing, and if you have to embed more hardware devices for processing, it will not be feasible, because the drone itself has its own control, flight dynamics and speed and communication devices. So we cannot expect a full-fledged hardware for image processing within the drone. So these images have to be processed for careful gathering of information, like number of people or the terrain or the number of things. In agriculture also we have a lot of usage. So this is image, or this is a processing, it's a process done within the drone, counting the number of trees or the terrain or detecting a animal intruder, etc. So the main point is that our drone has to do a lot of image processing stuff, and so we need a hardware, customized hardware, not only for the image processing but also with controlling the flight dynamics and the communication protocol within the drone. So things become very complicated, which cannot be done using a small processor like Arduino or Raspberry Pi. This can be used for simple applications for control, for entertainment, or maybe for child's play. But when you come to high-end applications like image processing, video tracking, object tracking, etc., so it needs very customized chips for these purposes. So we have to go for some hardware descriptive languages or some chips which is designed for specific purposes. Now, first among this is ASIC, application specific integrated circuit. These are the best option, or specific chips used to implement both analog and digital functionalities in a high volume and high performance. Now we are making it for our own application, and it doesn't have anything to do anything else. So it is very high performance, because we have our design, hand-picked design. We are design using our single application using our design team. That means it will have a high performance. Okay, Then what about other things? Yeah, it is have reduced power dissipation because it is optimized for our design and less area. So the contender of ASIC is FPGA, field programmable gate arrays, which but the problem with ASIC is they are not reprogrammable. They are fixed and they have the budget is very high because for designing ASIC we need a fabrication. We need to send our design, simulated design after mm, uh, after custom design of all the ports and all those we call chip out tape outs, or we call tape outs. We have to send the tape out fabrication industry to China or use or some industry fab. Then we get our design fabricated maybe in 1,000 pieces, 2,000, 10,000 pieces based on our product demand. And then you have to test it, and so the cost is much higher, at least 5 lakh in Indian rupees. So the cost of ASIC is much higher. Now let's next option is FPGA. So this is the image of ASIC. We have custom made our shape and size, everything we can design based on the library fab requirements and as well as our custom design. Now another FPGA field programmable gate array are also another option. Here it is low cost because buying a single piece of FPGA is already around 809 rupees, and its time to market is also very less, and cost effective reprogrammable devices. Yeah, and the flexibility, we can go and change the program. By changing the program we are changing the hardware within the FPGA. Within FPGA there are sea of gates. There is different sea of gates arranged LUTs. Basically they are multiplexers and they are designed to perform as any gate or any function, changing the inputs and select lines. So the investment is very low initially because the time because we can reprogram and you can test it with single piece maybe lakhs or 10,000 times, and the time to market is also very fast. So this is image of FPGA. So we can compare to FPGA and ASIC. Performance level, we can see the performance level ASIC is much better than FPGA. Why? Because we are custom making the ASIC based around only application, so it will be very fast based on the design, and power consumption also very low for ASIC. That is also very good, and size is also low because we are making whatever we require, only minimum area is required. Now what is the main thing? Time to market. Yeah, you can see time to market is much better than FPGA because we can make, if you know the programming Verilog, VHDL, we can directly program in within few weeks, and we can make our prototype within few weeks. And price is also first time non-recurring engineering investment is very low for FPGA, and it's very simple to use using some tools like Xilinx, ISC, or Altera is also giving Cortex, etc. A lot of tools are available. And unit cost, when we large scale production, our unit cost of ASIC is much lesser because we are thinking about 1,000, 10,000 scale. But a single 2-3 pieces FPGA beats ASIC. Now a lot of applications. Right now we are focused on FPGA because this is, for example, a hobbyist or electronic designer. For very few pieces of designing and very few applications, we will go for FPGA because of its reprogrammability, less time to market, and ability to play with it. So there are a number of applications of FPGA. Basically we have discussed already image processing and video image processing, which can be used in defense and etc. And in our drone we are also wireless communications. We need circuits, hardware circuits, which can be used in FPGA. It can be also used for scientific instruments, which we see in laboratory, CROs, DSOs, and all kind of functional generators, and digital signal processing kits. We can use FPGAs. It's also used in medical electronics and consumer electronics, home security system, lifts, etc., and security system, and monitor systems. Now this is typical FPGA. Its cost is around 800 Indian rupees. So this is typical. Although we are not excluding here is board. We usually need a board, or FPGA programming board, or we can make our own FPGA board. So how we are going to learn Verilog? So like any other language, we need to know the key phrases of that language. How we need practice. We have to learn grammar, syntax, etc. How this comes by practice. So this is the only way. But Verilog is much simpler than any complicated language. Now why we need Verilog for modeling hardware system, digital hardware systems. So we can model a system and based on specification, and then we can simulate it, then test it, and finally make the synthesize it, and we can understand how much hardware will be in our final product, or with the area, or with the power dissipation, how much performance we are getting, etc. So the main advantage of Verilog is as we already discussed, is the minimum cost and time, speed, area requirements. We can put our design to market, and we can avoid designer because we can test any number of times. Okay, so why Verilog? What is the difference between HDL or hardware descriptive language and procedural language? So one is this parallel processing. It is used for modeling hardware. Why is modeling hardware? Because hardware is different from software. Software is sequential or procedural, but hardware is concurrent, it's parallel. Every part of the hardware is activated at the same time, and we cannot model using a C or CPP or Java, etc. Because they take one instruction at a time and it processes that instruction and go to the next. But this doesn't happen in practical hardware. Hardware or the point of the hardware is activated at the same time. To simulate it that time, we need a parallel processing language. So we have special constructs and semantics within Verilog which can model this hardware, parallelism or concurrency of hardware. Okay, so let's go for more detailed Verilog. So Verilog is a HDL we already discussed. It's designed, started in 1985 defense-related project, and just it is used. It is slowly it has come up reducing its inefficiencies, and it is better and better to the better advantages for modeling the hardware, and basically concurrency, parallel activity flow, semantics, etc. And all these modern designs of all companies like Intel, AMD, Samsung, whatever chip companies you take, they have designed using Verilog. AMD, Pentium, Athlon, and thousands of ASICs design are also using Verilog. Okay, another content we have to discuss is VHDL. VHDL stands for Very High Speed IC Circuits, Verilog HDL. But we not use HDL in this course because compared to Verilog, it is more is less used in electronic industry. And another advantage of Verilog is its programs very similar to C. Okay, and number of codes of very less, number lines of code very less in Verilog compared to VHDL, and it's less verbose, less lengthy. VHDL is compared to like SA. For small thing you write a lot of codes, but Verilog is less, and it's easily adapt to modify. Right? If you know Verilog and C, this is compatible, and sometimes we can write a code in C and compile it to a HDL or hardware, and there are options. And sometimes we can use both VHDL and Verilog within the same project, and this also helps a lot. Okay, compared to other programming languages, we already discussed all very parallel, and it can model hardware structures using special semantics. Now, one of the limitations of Verilog is you cannot model analog things. Analog things are very difficult to model because of their range is very vast. It can range 1.2534 volts, but digital is only 0 and 1. 0 means low voltage, 1 means high voltage, so which makes things much easier for abstraction. So if you want to model analog, you go for Verilog A or Verilog analog. Okay, so from next lecture we'll discuss how to model Verilog.